Tim Panton from Voxeo Labs, and I'm going to talk about WebRTC, which is indeed coming soon to a browser near you, whether you like it or not. I'm Steely Glint on Twitter, and feel free to tweet at me. I'm going to have to dash off after this, but I will be around later. So tweet at me if you want to get in contact. So WebRTC, what is it? Brutally, it's about $60 million worth of intellectual property that Google bought and then put into the public domain as open source. And as a result of that, they've kicked off this development. I mean, there are other players involved, and you see at the bottom of the slide, but I think Google do need to be given credit for kicking this off. So what is it? It's the ability to add real-time voice and video to a website. So I've been going on, some of you may have seen me talk about this kind of stuff before. I've been going on about how the web is too silent, how it's not, doesn't support our best means of communication, which is speech. We're all really good at speech, and the web just doesn't support that very well. And this is the first time that it's going to be done properly. And I can say that. So it is, the other definition of it is that it's a pair of standards from the W3C and the IETF. So the W3C are defining an HTML5 API in JavaScript for it, and the IETF are defining the wire protocol and the low-level security stuff that defines what this is. So it is a real standard. It's not some ad hoc thing. The standards bodies are working on it and are producing a real thing. It's in Chrome right now. If you have a Chrome browser, you have it in there. If you're running the current release, it's not enabled, but a single flag and you can flick it on. Within about 5 weeks, it will be, by default, it will be on. Firefox, it's in the nightly builds. It's not in the production release yet. Gossip is that it will be in IE. When is not clear, but it will be in IE. Safari, we have absolutely no idea. Apple don't say. That's traditionally they never have. They've got a good track record of adopting W3C standards, so there's a good chance they will adopt it, but that's by no means a certainty. And the other players in the standards body include people like Cisco and Ericsson and Skype. So it's not a little obscure thing. Really serious players are behind it. And the key thing is there are no plugins, right? This is part of the browser. It's built into the browser. We're not using Flash. We're not using Java. We're not using ActiveX. And it's a standard API. So once the thing's settled, you'll be able to rely on it being in every browser. And it'll be, hopefully, compatible in the same way that browsers are always a little bit edgy. But pretty much, you should be able to rely on that API being there. And it can leverage, because it's built in, and built in particularly with it can leverage the resources of the machine, and so if there's echo cancellation built into the hardware, it can take advantage of that in a way that Flash always struggled to do, and video accelerators and stuff like that. And the other thing that's different about it, and it doesn't really belong on this slide, but I wanted to mention it somewhere, so I kind of snuck it in. It's encrypted P2P, so it's not. There's some quite interesting aspects to it in that the calls are by default encrypted. And by default, they're point-to-point, browser-to-browser, or browser-to-gateway. And they're using ICE and SRTP. So some fairly advanced telephony standards are used as the default underpinnings of this. So having said what it is, I want to say what it isn't. It isn't just a phone box on the web. I've done that, and it doesn't work. It technically works, but this is something different. This is a T.S. Eliot quote from The Journey of the Magi. And he says that he'd seen birth and death and he'd thought that they were different. And this is both of those. This is both an undermining of some of the existing things and a replacement of them with something that's different and better. It is, in my view, a new beginning. Voice on the web is a major thing, I think, and video. So if you're going to do this, you need to adopt web thinking. If you're going to use calls, in the web, you have to start thinking about them from the user's standpoint. And the user is sitting in front of a web browser and has a set of web-based expectations, web models in their heads. And you have to carry that through. If you're going to use WebRTC, you need to do this. So you can't build by the minute on the web. Nobody has successfully built by the minute on the web, and I don't believe anyone ever will. Almost all the transactions on the web are asynchronous, and that doesn't map very well to synchronous calling. So you have to think about how that should be modeled, how that should be done. And identities on the web are context dependent. It's not like your phone, which is a single number. You know, when I log into Facebook, my identity is different from when I log into a poker site. Or when I log into LinkedIn, my identity is different. So the identities on the web are context dependent. And if you're building WebRTC into your products, you need to think about that, because people expect that to be malleable in that way, because it's on the web. And the web isn't always on. So you can't assume that people will have a browser open 24/7 in the way that you can assume that they will have a phone switched on the majority of the day. So it's a different dynamic. You have to think about the user experience if you're going to put calls onto a web browser. And the other thing that's fundamentally different, and this goes all the way through, is that the web is used to having a dynamically loadable client interface. So the way that a given web page behaves, so the way that a LinkedIn page behaves, is different from the way that a Facebook page behaves. So you need to be aware of that and build, and each page will have its own interface and its own feel. And you need to think about how that should behave. And the other fundamental of the web is that browsing to evil.com should be safe. So you have to think about what that means in terms of your WebRTC standpoint, and that has a whole lot of impacts right down onto the protocols that have been used. So, you know, the SRTP and the ICE things are in there precisely to make browsing to an evil website relatively safe. So it isn't the same as the Digium phone or the Polycom phone on your desk, because they have a fixed set of firmware and a fixed set of behaviors. And if you look at these last two items, they mean that your web browser has neither of those things. And you need to think about that as part of your strategy for taking on WebRTC. So, but why would you do it anyway? I mean, why would you, if I'm saying it's not a phone box on the web, what is it? What makes it worth doing? And the answer is user benefits. You have to build a user benefit into your app that makes it worth the person's while to click the button to make the call. And those benefits are generally around tying in the other assets of your web presence. So things like the context. So, you know, you already know that this person's navigated halfway through your support pages before they make the call. And maybe you could feed that into the call such that when they get through to the agent knows all that. So that kind of context. They may have logged in and they may have a support identity, and you may know that at that point that they're one of your best customers. So you might route the call differently based on that. So the identity is important. Conversely, if you're a recruitment site, you might want to guarantee a level of anonymity in the call such that the first touch of that recruitment or dating site is anonymous, so that people feel comfortable getting started, and then maybe they'll start revealing more when they choose to. And then there's a whole business about permissioning and rendezvous. I don't know about you, but there are very few people from whom I accept spontaneous phone calls gladly. Generally, I expect to have a negotiation with them about when they're going to call me and under what circumstances. I mean, you know, there are people who I will take a call from out of the blue, but it's a limited set, and it's a limited set of circumstances. So you need to think about how that rendezvous could be constructed, and if the website aids in that, then you can get a much better user experience. So there's a genuine user benefit from having maybe a negotiation over a Facebook page or over a LinkedIn page or over your app, to the point where you decide that a call is worth it, that you and the recipient of the call have decided that this call is worth having because the thing has got too complicated to do in text, or it genuinely needs voice to explain itself. So Slight shift of gears here, but one of the ways that you can start doing, getting your hands onto WebRTC is Phono, which is a project I work on. It's a free open source jQuery plugin, which allows you to embed SIP call into your website. The aim is to make that as simple as possible. So if you've got a jQuery capable web programmer, they should be able to do this without any problem. We also have a native layer for the mobile platforms. If you want to build an iPhone app or an Android app, then we have a native layer for that as well. Again, that's open source. And as it includes an XMPP-based messaging section. And we finally got to the point where we've got an echo canceller available on all platforms if the hardware supports it. So you actually, you can plunk down your iPad and talk to it and listen to it without having to kind of find a pair of headphones or something like that. So what the nice thing about Phono, and the way that it means you can get started right now, is that it has multiple backends. I mean, obviously WebRTC is the future backend, but for the moment, if you're on Safari or IE or something, then you can fall back to using the Flash backend, and you get a reasonable result. Not as good as with WebRTC, but you'll get a reasonable result. On iOS and Android, we have a PhoneGap plugin, which allows you to build an app based on HTML5 and Phono and use that. And then, as I said, on the mobile platforms, we also have native for in Java and for Objective-C for iOS. So this is the simplest possible Phono call. It's as soon as you open a page with this in it, it will make a phone call to this app. So it can be a SIP address, or in this case, it's a Tropo app, which is one of the other products I work on, which is a cloud-based telephony platform. And messaging is equally simple. And this is an interesting example. It's actually, don't do this, because it's a bit risky. But what I've done is it evals the incoming message. So the incoming message can have a piece of JavaScript which says, change the page to green, or change the sort order. And when we're done, I could do or upload my bank account or whatever. So you need to validate what that message is. But the point is that you can make the page interactive by sending a message back up from the IVR or from the back end. And fingers crossed, I may demonstrate that later. So at this point, I'm going to switch presentations, and Josh Colp from Digium is going to talk about where asterisk is in this picture, and then with any luck, we'll do a demo at the end, maybe.
Everyone cross their fingers for the eventual demo. So yeah, Tim has talked about WebRTC in general some, but I'm going to focus on what asterisk can now do as of asterisk 11 with WebRTC and some possible applications that may occur in the future. But before we get to that, I'd just like to introduce myself a little bit, so it might be easier for some of you to come approach me if you have questions later. I'm a Canadian. I hail from Atlantic Canada. Yes, James just said he finally realized. I've been doing asterisk development for quite a while, 7+ years. I once tried to figure out how long, but I lost track, really. And I'm the guy who did the WebRTC support within asterisk itself. I've basically did all the code for that. So yeah, our WebRTC support is broken out into 4 parts. We have a WebSocket server built in using our HTTP server. We support tunneling SIP over that WebSocket Transport from JavaScript in the browser. And as ICE-Stun and Turn are a requirement for WebRTC, we implemented those. And just a little point on that, the ICE-Stun and Turn support is not just for WebRTC. That can be used with regular SIP clients that are using the UDP transport, TCP, or TLS. So you can get some better NAT traversal through that. And then SRTP for the encryption of the media. So WebSockets are a really simple way to establish a connection to asterisk and have bidirectional data flow. Right now, the only thing that's really using that is SIP itself. But in the future, I expect that other developers will see ways they can use that. For example, last night, using it for Manager was brought up. And I've explored that, and it seems like a viable thing that could be done. So within JavaScript, you could use WebSockets to establish a Manager connection to Asterisk and then perform actions or receive events. And we support the RFC and a few of the additional specifications. There's actually about 5 of them. As people have seen, they sort of went through revisions to see what could be done and sort of had disagreements about things, but we support the major ones. And then the SIP WebSocket Transport is used for having a SIP stack written in JavaScript executed in your browser and having that SIP traffic reach Asterisk. There is actually a specification out there for it, an RFC that's eventually will become official. And this also supports encryption like HTTPS. And all of the features that already exist that are available using UDP, TCP, or TLS are available over the WebSocket Transport as well. So it's the full ChanSIP is available to you. And ICE in turn, as most of us probably know, NAT right now is everywhere. And when WebRTC was being discussed, that was obviously an issue. So they chose the ICE in turn specifications to overcome that. So that is now supported as of Asterisk 11, and we use the PJ NatH part of PJ project from the Telu company. It's got some really good interoperability, and it just seems to work. And there's a lot of additional products out there that are using it for NAT traversal. And right now, this is implemented as part of SIP and also as part of ChanMotif, which is our Jingle, Google Talk, and Google Voice module that's new as of Asterisk 11. So SRTP, just like it seems everyone on the planet, we use the libsrtp library. It's pretty standard. And we do SDES for key exchange, and as of Asterisk 11, we do DTLS SRTP. If there's anyone out there who knows of an actual client that supports DTLS SRTP, I would really appreciate you coming up and saying, here's the name of it, because there's not a lot of implementations out there, but I'm hopeful that as things progress, more clients will actually get that implemented. And this whole WebRTC work hasn't changed our approach for optional encryption. It's just flat out not supported. Those of us behind that just don't believe in the idea of optional encryption. If you have a valid argument on that, I would enjoy discussing it. And then putting it all together. So there's a few SIP JavaScript libraries out there, as scary as that might sound to some of you. The most popular being SIP-ML5, which is available at sipml5.org. So using a SIP stack written in JavaScript running in your browser, it can then use WebSocket to talk back to Asterisk. And then it's just regular SIP there. When calls are received from it, they're parsed just like a regular SIP packet. They're identified, the SDP, all of that is normally done. And then PJ NatH is used to do this, the NAT traversal. And once all of that is done and everything's good, it then uses SRTP to encrypt the media back to the browser. And like Tim said, no plugin required for browsers that currently have it implemented. And just like a regular channel from your desk phone, you can send that call anywhere you want in your dial plan, or AMI, if you want to interact that way, fast AGI, AGI, etc. It can be anything that Asterisk currently supports. So yeah, some possible applications. These are just some brainstorming things that I've done and also discussed with others that they've brought up they'd like to see. The first one being a simple WebRTC to UDP TCP SIP translation gateway mechanism. To implement WebRTC, it is an effort for the vendors, us being one of them. So there may be situations where where your vendor just can't, they're just not going to use or implement WebRTC. So Asterisk can perform that translation for you. It just fits right in and does the translation. A lot of companies are using that for testing WebRTC, for example, with an existing infrastructure. Then click to call with an existing PBX. If once WebRTC really does get into the mainstream browsers, it's possible you do have to take into account security and such to have a WebRTC-based application available to people on your website, et cetera, that just connects directly into your PBX without really any extra effort, because it's built into Asterisk 11. And a tightly coupled soft phone. As Tim was saying, since you can push out the full experience and environment, you can really make it tightly coupled with things. For example, you could use WebRTC for the media part, and then you may have an AMI-based control panel or something sitting right beside in the same web page. And a web-based game voice chat room, a la Facebook games or the other stuff that takes up numerous hours of our time. It would make it really easy to do something like that. And then obviously web-based conferencing is always a nice subject. No plugins, easier for the user. And call center agents. Since you can push out that full experience, you can custom craft things to your environment, your call center infrastructure, your CRM system, your trouble ticket system, etc. So yeah, if you do want to chat about this, WebRTC, I'm happy to. I'm happy to chat about anything else. So you can email me. I'm also available via XMPP. And I am on Twitter, so you may follow me, and I do respond to messages, usually within about 30 seconds, actually, provided good internet is available. And also, if anyone has any questions before our potential not going right demo, both Tim and I would be happy to take them at this time. Yes.
Just regarding DTLS SRTP, you said you're using that for the Websocket Transport, but it's not very commonly used. Is it mandatory to use for WebRTC? Or?
Has it become mandatory yet?
No, it hasn't become mandatory, and my personal opinion is that it won't. There are too many people who are keen that it shouldn't be. But that's just my opinion.
Yeah, the thing about WebRTC is that it is still evolving and decisions are being made. So right now, for example, video codecs that are required or mandatory to implement are still not completely decided. There's a debate between VP8 and H.264. So the same goes for security. Of course, there's pros and cons for each, but there's no decision yet. And to really make sure that in either case we're okay, we've got DTLS SRTP now. So no matter what the decision ends up being, it should just work. Any other questions?
So I might be worth emphasizing the issue there. The thing about the issue is around traditional SRTP, the keys are exchanged by the signaling channel. And that, particularly if you're involving a web server in that, there's a risk that the keys will get put into web server log files. And so the idea with DTLS SRTP is the key negotiation is done over the media channel, and at no point does it get percolated up to the signaling channel or to the web browser. So the web browser is unaware of what those keys are. So it should make interception more difficult. That's the philosophical reasoning for it. Whether that actually turns into real hard facts is unclear to me.
And now the exciting live demo that may go horribly awry. When hotel internet is involved, you never have to.
So I'm going to do the demo once and see if it works, and then if it does, we'll talk about what it was that you saw. And if it doesn't, we'll kind of wave our hands a lot. So this is a plain Chrome browser.
Welcome to the Feno test call. Please choose a test. Press 1 for DTMF, test 2 for landline, test 3 for wideband, test 4 to join conference, 5 to test mic, 6 to join rainbow dash call, 7 to be called back, 0 to hang up.
Ain.
Got a DTMF 1, okay. Please choose a test. Press 1 for DTMF, test 2 for landline, test 3 for wideband, test 4 to join conference. Wideband test. Please choose a test. Press 1 for invalid choice. I did not understand. I heard no match. Please speak better Dutch. Please
Null.
invalid choice.
Come on.
I did not understand. I heard no match. Please speak better Dutch.
Null.
Please choose it. Goodbye.
So in a sense, what you saw there is actually staggeringly simple. I'll show you the source for it. It is literally that much code. And the interesting aspect, there are two interesting aspects, one of which is there are no plugins, all right? I just want to say that again. There are no plugins. This is just Chrome. This is Chrome beta, as it happens, but in 4 weeks' time, this will be the release version of Chrome. So it's, there's nothing magic in here, and there's just not a great deal of code. Mentioning the messaging thing here, what we've done is talk to an IVR, and the IVR, as well as reading the messaging, reading the prompts back, it also sent them over the XMPP channel. And here, I didn't do an eval, I just set the HTML element there, so that I actually have my IVR sending up the prompts to the screen. And so it stays in sync. There was no, what it said was what it saw, what you saw, which for a user benefit, that's fantastic. I actually use this a lot, because if I've forgotten what the options are, I can look at them. So that's the kind of simple to implement user benefit that you can convey to your users immediately using your existing infrastructure. So having said that it was simple, I'll tell you a little bit about how this demo actually worked, and then you'll see why neither of us were confident that it was going to. So this is Chrome. This is Chrome calling into the Phono Gateway, which is running somewhere on the East Coast on Amazon, which negotiated the signaling. And it sent the signaling to an asterisk, which is running in my home on a Raspberry Pi. And the Raspberry Pi was doing, and this is impressive actually, it was running DTLS, running SRTP and the ICE negotiation. It set up a direct media transport between here and my home. And then the asterisk was then connecting out to Tropo, which is our cloud-based telephony API. And Tropo has that IVR menuing system. That's an app I've written for testing Phono. I built this app, this demo, and at some point in the demo, I realized that I had a really serious problem, which is that they haven't agreed the standard code, the standard API for DTMF, sending DTMF. So I had this demo with no DTMF, and it was like saying, press 1 to do, and I was thinking, I don't know what. So fortunately, Tropo supports speech to text, does good voice recognition. So I built that, but unless you've got a really good echo counselor, you run the risk of it hearing the prompts and immediately talking, basically responding to itself. So the hack was to switch languages so that it reads the prompts in one language, and that it's a hack, I admit it. But I speak acceptable Dutch to the point where it pretty much understood what I was doing. So there you go. That was a hugely complicated demo to do something really simple. But I hope you can see that there are real possible user benefits in doing that, and that the Raspberry Pi is a fantastic platform. So, questions? To me or Josh?
Yeah.
Hey.
Regarding echo cancellation, you said that there's hardware support for echo cancellation. Do you see it very widespread in modern sound cards? What platforms do you see hardware cancellation?
So most of the major operating systems offer APIs that will enable echo cancellation if the hardware supports it. So in Windows, there's some flag you can set on the... Now, whether the sound card supports it is to do with the hardware build. But I think you'll see it more and more in laptops, where the geometry of where the microphone and the speaker is a known quantity. And certainly on the tablets, that's definitely the case. But No, it isn't. It isn't that common. But if it's there, then at least it's available to be used by the infrastructure in a way that's much harder for something like Flash. More questions, perhaps? No? So feel free to come and find me this evening. I've got to dash off, but I'll be back later.
Tim, I have to say that was easily the riskiest demonstration I've seen in a long time, and it worked.